So here in this particular video, we have a 1 kilogram block initially at rest at some height h. It's going to come down, collide with the stationary 1.5 kilogram block, and then they couple together or stick together, and it moves to the right at a rate of 5 meters per second. And the question wants us to find what was the initial height of this 1 kilogram block. All right, so before I attack this, I'm just going to go ahead and identify these blocks just so it's easy for subscripts. I'm going to call the 1 kilogram block block A. I'm going to call the 1.5 block B. And then so here's block A and B stuck together. So I like to point out this is a backward problem. It's a backward problem because you're given the result after the collision, and then you're asked to find the initial height. So really, this one is going to go from right to left, so it's going to go backward. So because it is a backward problem according to the statement here, the setup here, I'm just going to go ahead and start with conservation linear momentum. I'm starting with linear momentum because the final frame after collision is given. Okay, so I can figure out how fast the initial speed of block A is as it comes down the frictionless ramp here. All right, so here I have net momentum initially equals net momentum in the final frame. I'm just going to break it up in two terms. There's block A and block B. You can call it 1 and 2 if you like. So here is PAI plus PBI equals PAF plus PBF. But before the collision, the 1.5 kilogram block, which is block B, was just stationary. So I'm just going to go ahead and cross this term out because it is stationary, it has no momentum. So I'm just going to go ahead and break PAI out into MAVAI. On the right side, as you can see, I group MA and MB together because it is stuck together, so they move as one. Therefore, it just moves off at the same final velocity. VF here does not have an A or B subscript. So other than that, I'm just going to plug in values. MA here is 1 kilogram. VAI is actually what I don't know. I need to figure out how fast was block A coming downhill. If I know that, I can figure out how fast it was, how high it was initially. Okay. On the right side, MA is just 1, MB is just 1.5 kilogram. VF here is given as 5 meters per second. And if you simplify this on your calculator, 1 plus 1.5 is 2.5. 2.5 times 5 is 12.5. On the left side, nothing has changed. I just carry that down. So to get VAI by itself, you would just divide both sides by 1 kilogram. So if you're keeping up, as you can see here, the unit kilogram on the left side and on the right side will cancel. So it only leaves us with units of meters per second. 12.5 divided by 1 is just 12.5. So this one is pretty straightforward. No tricks or trap here. So VAI is 12.5 meters per second. So essentially what this is telling you is, watch my diagram, right? It's telling you when block A comes down to the bottom of the ramp, it is moving at a rate of 12.5 meters per second, because that's what conservation linear momentum just told us. Well, if I know the speed of block A at the bottom, I know how much kinetic energy it has. Well, if I know how much kinetic energy it has, I can backtrack that to how much potential energy due to gravity it had at the very beginning. If I know that, I know H. So to continue, I'm just going to go ahead and solve H by setting up conservation of energy. The kinetic energy of block A at the bottom, which is KEF here, must have came from the gravitational potential due to gravity at the start. Okay, so here's my I for initial. So PEI equals KEF. So if I were to go from left to right, this is PEI. All this PE will be converted to KEF at this point. All right, other than that, I'm just going to go ahead and break up PI into MGHI, KEF into 1/2 MVF squared. But as you can see here for mass, if you're keeping up, really from at this point, I'm doing block A. So here's mass, but which mass is it? Mass of block A. But it doesn't really matter anyways, because as you can see, mass on the left side and the right side will cancel out. So really to find HI, I'm just going to divide both sides by G. So this is VF squared divided by 2, and then dividing by G will just cause the 2 and the G to combine in the denominator. So VF squared stays on the top, the 2 in the denominator stays there, and then the G that's in the numerator on the left side, because you're dividing, will just cause G to join the denominator on the right side. So to find HI, I need VF squared divided by 2G. But as you can see here, the final velocity, which is 12.5 that we calculated. So even though on this side it's just the initial of block A, this is before the collision part, but the initial velocity must have came from the final velocity as it came down the ramp. So VF over here is just 12.5. We're going to square that, divide that by 2, and G being 9.8. So if you simplify this on your calculator, you should get a value of about 7.98 or about 8 meters. Okay, so the initial height that block A started from was about 8 meters above the floor. All right, that is your answer for this part. Stay nerdy, don't be whack.